Hello to the aviation community out there at the screens. I welcome you to this year's EASA DOA and CT workshop 2021 for the virtual lecture on the certification memorandum on large antenna installations. My name is Wolfgang Kaufmann. I am a structures expert and certification manager in EASA's large aircraft department. The next slide brings us to the content of this presentation. We will look at the general purpose of the certification memorandum and explain the current existent regulatory framework. Furthermore, we'll briefly discuss technically specific design features of antennas, keywords on that, classification of large and small. This turned out not to be easy in the past, so we got lots of comments on for this. I will report on the status of the CM and conclude with an outlook on possible future extensions and updates for the CM. Why does the EASA publish a certification memorandum for the installation of large antennas? So let me say it in the words of John F. Kennedy. We choose to give you guidance for large antenna installations on pressurized fuselage, not because it's easy, because it's hard. So, well, he said this in the combination in the situation when they were going to the moon. But we think it's really hard because you must focus on structural requirements and adverse effects such installations may have on the aircraft or persons on the ground. And this is more or less covering the basic regulation Article 4. Especially non-TCH applicants need support not having access to all relevant TCH data required for such installations. So, for example, we have fatigue and damage tolerance data or stresses on the surface, and this has to be re-engineered somehow. Okay. Let us come to the related regulatory framework at EASA. As a kind of preliminary tool for handling applications on large antennas, EASA provides since some time two generic CREs. CREs are certification review items for CS25 aircraft. The first one is structural certification criteria for large antenna installations, and the second one deals about vibration and buffeting and compliance criteria for large external antenna installations. Those CREs are largely harmonized with the FAA generic issue papers and their related policy statements PS/ANM 25-17 on structure certification criteria for antennas, radomes and other external modifications. So they have extended this a bit to other external modifications, but I will come later to it. We may have an extension as well on this CM in the future, so depending on the customer needs, so what they want to install. Let me now come to the technical specific design features of antennas. Those require a classification, of course, as mentioned before, containing their individual footprint for small and large. We have defined small antennas shall be confined between two adjacent fuselage frames and two adjacent stringers. Please see the upper picture on the right side. Normally there is no extensive support structure under and related justification needed for this kind of small antennas. But there may be some points where you would have to reevaluate. There is no black and white. There's a transition between large and small antennas. It should be, for the large antennas, they are spanning beyond the small antennas footprint and involving more sophisticated supporting substructure. Please see the lower picture on the right side. So we have a span of the structure over more than one frames and more than a few stringers. So it's a really huge piece of structure. And it should be noted that typical antenna installations are classified as major, non-significant. But this classification, as already mentioned, needs to be confirmed. So for every antenna installation, especially when the size, shape, or location are not conventional. For an example, an AVEX antenna would of course not fall under the category non-significant major. It would really be significant. So finally, we would have discussed before in detail what the antenna is. Retroactive requirements, of course, as Part 26, for example, will also apply for the approval, not only for foreign approvals, as mentioned on the slide, so it's also for approvals with the EASA. Also, aerodynamic, respectively aeroelasticity related subjects of antennas will be covered via a generic CRI on vibration and buffeting through an ESF, a so-called equivalent safety finding. It contains guidance on the use of computational fluid dynamics analysis and the need for additional flight testing. And particular attention should also be paid on the aerodynamic interference effects between multiple antenna installations. So service experience has shown that this effect can be significant with different combinations of small and large antenna installed. The current progress status of the CM is unfortunately marked by COVID-19 issues as well as a lot of things, and prioritization of other related tasks and projects had to be done. But the good news is the available tools, which I have mentioned before, so this is the generic CRIs, are still valid, and they give you enough information. And the comments from the CRD are hot topic related, and we are just trying to incorporate them into the CM. And those took really some more effort to be adequately considered with the CM. For example, the fatigue and damage tolerance issue is quite a huge task. The publication should still happen in year 2021, rather in December than before. The outlook is that we are thinking of extending the application of the CM to other fuselage or wing-mounted pods, depending on the market request, so depending on what the customers want to install. A regular update, of course, of the CM will account for future specific design concepts requiring additional verification. And EASA will, of course, be continuing harmonization with FAA policy on antenna installations to have a minimum of regulatory difference for the applicants who are also seeking an FAA approval. Thank you very much for your attention, and I'm looking forward to your questions.